Hi, everyone. Thanks for coming to our session. My name is Mano Marks. I'm a developer advocate at Google. And we have Chad Killingsworth here from Missouri State University. We're going to be presenting on Map Once, Map Anywhere. I'm going to be talking to you today about how to create cross-functional, cross-platform maps using the Google Maps API version 3. Now, some of it's going to be a broad overview of different options, and then I'm going to drill into some specific code, and I'll talk to you a little bit more about the specifics of what I'm going to go into in a minute, but I just wanted to give you that notion so that if you're session shopping right now, you have the option of moving on to something else. Okay, so Map Once, Map Anywhere, developing geospatial applications for both desktop and mobile. And I will commit at this point to that being the last time I actually read directly off the slide. So what do we mean by write once, run everywhere? This is an obvious takeoff on one of these slogans that often goes around the web or around computer science, where you talk about applications that will run on any type of platform. The farthest back that I can remember it was Java. I'm sure it goes back before that. The idea then was that you could write an application that would run on Macs or PCs or anything using the Java runtime. In this case, what I'm going to be talking about specifically is different kinds of devices that can implement the Google Maps API version 3. And particularly looking at desktop and laptop implementations versus mobile implementations, and taking a look, kind of just giving you a sense of the different classes of devices that we're talking about. The question is, why are we talking about this? Now, for most people who live in the United States, this is your primary method of accessing the web, a laptop or a desktop computer. For most people who live outside, one of these devices is the primary method of accessing the web. So Google looked at this problem a little over a year ago and decided that for the foreseeable future, mobile would be hot and desktop would be hot. These are two platforms that we needed to support. And so we came up with, for the Google Maps API, we came up with one API that would work well on both of these platforms. And we wanted, in doing so, we wanted to save you development time. We wanted you to be able to create one map that would work in multiple places, and you wouldn't have to recreate that map. We'd also wanted to give you faster development turnaround time. So we were looking around at our Google Maps API, which is on Android, and the Google Maps API, which is on the iPhone, which is an Apple API. And we were thinking about that and thinking about the fact that, if you need to fix a bug or you need to release a new map, you'd have to release a new application. So we wanted to save that pain for you. And we wanted to give you the most featured API, the most featured mapping API that we could provide. One map to rule them all, kind of. I just had to throw that one in. OK. So we're doing this on all the geotalks, at least today, just to give you a little sense of where this, which APIs we're talking about. I'm going to look over to this monitor to my left. We're looking primarily at the JavaScript API version 3. I'm also going to talk about the Static Maps API and some of these web services that are available within there. I'm going to look a little bit at Ajax Search API as well, and many of these things are related to the entire topic. This is a general overview. So as I said, I'm going to do this overview of the Geo APIs, which I just did. I'm going to talk about the different options for mobile development, and then I'm going to talk about different user interface considerations that you might need to think about for mobile devices compared to laptops or desktops. I'm going to talk about geolocation, particularly looking at HTML5 geolocation, but looking at some of the options that are available both in HTML5 and that Google provides. And then Chad is going to talk about his experience developing a real-world mobile application using the Google Maps API version 3. So just a quick note, there's a wave up. There are live notes being taken. There's somebody out here in the audience taking notes on my session. I don't know who you are. If you have any questions, feel free to post them in there. At the end of the session, we'll pull that up on the screen, and also have you can ask questions using the microphones. Now, if you want, I'm going to actually put on most of the slides at the bottom, you'll see the URL there. So that will be on most of the slides, so that you don't have to quickly log into Wave right now. But if a question comes up, that'll be available to you. Okay. So I wanted to talk to you an overview of some of the options for doing Google Maps on a mobile device. And I talked to you specifically about maps on mobile because I think the other ones are fairly well known. Now, some of this may be familiar to some of you from previous presentations. I'm not going to spend too much time on any one of these options, but I just wanted to go through them. The one that we like the best, because as you will hear over and over again from Google, is Google's betting on the web. We believe in the web, and we believe in in browsers on mobile devices. And in mobile devices, particularly in Android and iPhone devices, and we hope to expand this to a larger class of mobile devices that will start using WebKit, particularly, or any full JavaScript support. So we support, using directly in a browser-based application, having people navigate directly to a particular page. We recognize that that's not something that's not the only option that's out there, and that there might be some other considerations, and I'll talk about some of the other reasons for using other things. But there's also the iPhone native API. So within the iPhone SDK, there's MapKit. There's the Android native map view and related APIs. And there's also an option to do a hybrid native application which embeds a browser in it. So takes advantage of both the best and worst of both worlds, which is you write applications for individual platforms, but you embed a browser with it and load the Google Maps API version 3. And then finally, there's the Static Maps API, which is essentially an image server. Okay, so first I want to do a comparison. So you can see here the major features of the different Google Maps APIs on the different platforms. And the first column is, of course, the Maps API version 3. And we've made a lot of strides in the last year to get a lot of extra features in, and of course we'll continue to iterate on those. And then you can see the iPhone and Android columns as well, which do provide you with some additional features. And there's everybody has the basic functionality of giving you a map. Everybody has the basic functionality of giving you some markers to put on that map. All but the Google Maps on the iPhone give you direct geocoding access. The iPhone gives you reverse geocoding, which all but Static Maps API gives you. So you see there's sort of a heterogeneous, you have to kind of look which API supports which thing. I have a little asterisk there by the polygons and polylines, because both Android and iPhone prior to version 4.0 provide a way to do overlays, but not ones that specifically make it easy to make polygons and polylines. So that's why there's that asterisk there. And I do note that in the iPhone in the 4.0 SDK, which was recently released, then you can create polylines and polygons. So you see there's quite a few services that are that are available within the Maps API version 3 that are not available in the rest of them. And of course, there's Street View. So those of you who've been to some of the earlier talks today, both in Dan Lee's talk earlier, he talked about our new release of Street View, which is available now in the Maps API version 3. There are also native APIs in the iPhone and Android platforms as well. Of course, there's no Street View in the static Maps API. Now, just to be clear, when you think about Street View, you probably think about Flash, because in version 2, the Street View API allowed you to embed a Flash player. But now, with the new Street View API, we support HTML5 Canvas 2D, which is one of our preferred rendering platforms, if the browser supports it. We basically detect what the browser will support and then render there. We'll support HTML4, which is what is generally we use in mobile browsers. And then finally, and this hasn't actually been mentioned, I believe, yet today, we support WebGL. So WebGL is in the latest, I believe in all the latest builds of all the modern browsers. It's definitely in Chromium, which I have running here. So WebGL is basically an infrastructure for taking advantage of a much higher performance graphics libraries that are available on, as I said, in most of the modern browsers and available on all modern machines. So that's very exciting. And I will say, just to reiterate this point, the Google Maps API version 3, which supports WebGL, HTML5, HTML4, it doesn't require you to make any decisions about what to support. We will figure all of that out for you. We'll detect what the browser is doing, what it's capable of, and then display the appropriate Street View at that point. Okay, so let me do a quick demo of this. Just wanted to show you. Okay, so this is a demo that I'm going to come back to when I talk about geolocation, and it actually shows you some of the perils of geolocation. But the idea here is that it auto-detected my location, which you can probably tell is not actually where I am. And I'll talk to you a bit more about that when I talk to you about geolocation. And Chad can probably tell you any travails he has with that. But I just wanted to show you Street View and what it looks like here. And I'm going to just drop this in here. This is Street View in WebGL. You can see it's very highly performant, and we actually have one of the engineers in the audience, Mark here, who created this implementation and can tell you a lot more about it, and I believe will in one of his later presentations. So anyway, that's very exciting, but it's a lot more exciting to think about it in terms of what does it look like on a mobile device. I'm about to show you something that we haven't talked to you a lot about in previous talks on mobile devices, which is I'm going to show you what this looks like on the iPad. Let's see if the iPad does a little bit better job of picking up the location. It does. So you'll see here it actually manages to find us in San Francisco, which is great. And so here I'm going to drill down a little bit into San Francisco, right around where we're located. and show you what this looks like. You'll see up here in the upper left corner, the Street View control is there. And I'm going to drop it in. And then it's just going to take a moment as I think you are probably all aware of the Wi-Fi network having been under a considerable amount of stress today. So this is Street View in a browser on a mobile device. This is on the iPad. So I'm very excited to be able to show this to you today. And then just to, I actually meant to do something today, which was to pre-cache the imagery for this location, and I didn't. So I don't know if you saw how fast that came up. Oh, I managed to turn the whole iPad there, didn't I? That's one of the things you have to prepare when you're doing these presentations. So you can see here, there's it's moving a little bit more slowly than it would on the web because this is doing HTML4 Street View instead of WebGL, which is, I believe, our most performant version of it. And I could show you a similar thing on the Android device, but I think I'm moving a little bit behind where I wanted to be. So it's actually very easy to set up the code for to add Street View to the Street View control to your map. It's actually just this first line here, this first couple lines. Now I'm over to the right. You see map.setOptions and Street View control true, or you can do it when you create the map. You add that in. So that's it. That adds Street View to your map. If you want, you can do quite a bit more, and I don't have time to get into the full details of what the capabilities are, but you can also create it in a separate panorama. So you see here, I create a separate panorama and then set its position. And then, of course, if I want to actually do it entirely without a map, that's what the code looks like. Okay. So I'm going to jump back into, sorry about switching the slides there. I wanted to talk to you about the different options, again, as I mentioned earlier, the different options for coding with Google Maps API on a mobile device. So the first one here is browser-based maps. And the advantage here is that a browser gives you full JavaScript support. It lets you access some of the features that are on the phone, particularly around geolocation, and sometimes on phones you'll actually get access to local storage and that sort of thing. You can write your map once. So this is the big point. This is the end point of the talk. You could probably go home now and you'd have learned the major point here, which is using the JavaScript browser-based map. That's what we consider the best answer. It allows for rapid development. You create the web page on your server, and then it gets loaded. There's no changes that need to happen to the application that loads it because it's entirely happening within a browser. The next time somebody visits the site, they get the most recent version of your page. You don't have to submit your applications to the App Store and get it approved, or the Android Marketplace. You don't have to get any sort of approvals there, and you don't have to make your users download the application. On the other hand, one of the disadvantages is you don't get the discoverability that you would otherwise have within the App Store or the Marketplace. So on the flip side is you have the native APIs, sorry. So you've got MapKit and MapView on the iPhone and Android, and these are closely and tightly integrated with the individual phones. And if you're only developing for an individual device. If you're only writing an iPhone application or only writing an Android application, it's a pretty decent choice. You don't get as many of the features as you do in the JavaScript API, but if you just want to code in Objective-C, or if you just want to code in Java, that's one of your options. You have a little bit better performance as well. It's a little bit, because it's more tightly integrated with the operating system and not running in a browser, there are some better performance points. On the flip side, the development's a little bit harder, and you can't repurpose code that you did in, say, in JavaScript. You can't repurpose that for another platform. So as I mentioned before, you can embed a browser within your applications, and that would be Webview on the Android or UI Webview on the iPhone. And that gives you access to additional features of the phone that might not be available through the browser, that you can then push into the browser through some JavaScript interface. It allows you to keep doing the rapid development of the map piece of it, but also to take advantage of some of the advantages of iPhone and Android development. On the flip side of that, you still have to go through your App Store deployments, and you also have to then develop for each individual platform. Of course, a strategy could involve both doing hybrid applications and having a plain website that people could discover in other ways as well. And then finally, I want to mention the Static Maps API. I think my image died out here. Yeah. So the Static Maps API, which is basically an image server. It'll send out to any browser. It'll send out an image of a map, and it's actually now quite customizable and very highly performant. So you've got, the image of the map sends it out. You just put it in an image tag in your web application. You don't need to support JavaScript in the browser and the platform, so it can be used on a much wider variety of platforms. But you don't get any of the modern features of a modern Maps API. So no map slippiness; it's just an image, and any of the other features, you don't get any dynamism in that. So. Okay, I'm getting a little concerned about my time, so I just want to talk to you about some of the different user interface considerations that you might run into. And actually, before I do that, I want to talk to you about just some of the different platforms that you might run into. Think about this. Screen size is a pretty big deal. So when you're talking about a desktop or a laptop, screen size is not as much of a big deal for a web page, right? If your map is 25 inches across versus 15 inches across, it's still a pretty big map. You still got a lot of details on there. But if you're developing for an iPhone or an Android device, an iPad, which has is somewhere in between, or a desktop browser, or this is my Static Maps API image there. Those are all very different platforms. So I just wanted I want you to think about that when you're thinking about the development and what the implications of that are. And go back to this slide. And just some of the things that you might think about are screen size. So when you're creating your map, make your divs flexible, right? Don't set absolute pixel boundaries on them unless you know exactly the platform that it's being displayed on, because you won't necessarily know the size of your screen. Vary the Chrome, the stuff that goes around it, by the browser that's accessing it. So if you know that, you just put in some dynamic style sheets. Say if you know that it's on if it's being loaded on a mobile device, then you know that you don't necessarily want to put Chrome around it. You might want to put a tab instead, so that somebody can get to, say, session information at Google I/O on a separate tab from the actual map. But if you're displaying it in a browser that's sitting on a desktop or a laptop, you might want to put a whole bunch more stuff around it so that people can get that access to that information. And I just mentioned session information at I/O. I wanted to show you one of the apps that's, that you might have seen. Now this here this is the Google I/O map. So how many of you downloaded the Google I/O application on your Android device? This is the map that shows up in that. It's the exact same map. It shifts the user interface. And you'll see here as I'm moving around. Sorry? Not centered? Oh, sorry. When I practiced this before, I didn't have a cord plugged into it, so let me just pull that out. Maybe that'll be easier. Which is why I had the cord plugged into it. Yeah, that's another danger in creating for mobile devices. So you'll see here, I didn't actually go through, because I wanted to show you what the performance actually looks like. I didn't go through and pre-cache these tiles either. So that's actually fairly high performance, and including, by the way, some of these tiles are custom tiles, where you see the lunch cafes and that sort of thing. That's custom tiles that were created specifically for this application. So if you have an Android, you can download this and put this on your phone, the Google I/O application. If you don't, ask somebody who does. So you can see there, that's a nice hybrid application. Okay, so keep in mind too that people are going to have to do touch events, right? Which may impact what you put in your user interface. People are going to have to actually physically touch things in order to get them to open up. So if you want to have a map marker there, you're going to have to figure out what is the size on the screen, but also make sure that things are accessible, easily touchable by somebody particularly like me who has very large fingers. And also think about if you're doing a native or a hybrid application, you get some of the native look and feel of the application. Now there are some projects out there to try and help you get that native look and feel within a browser application. So IUI is one example of that. But that's something that you might want to have as it's always a trade-off, right? If you're sort of masking your application as if it were a native application, that kind of tricks your users into thinking that it is a native application even if it's in a browser. On the other hand, maybe that's what you want. Maybe not necessarily tricking your users, but just presenting them with a fairly consistent user interface. So that's one of the things that you might want to consider. Okay, so I'm going to spend a few more minutes here talking about geolocation. Now, geolocation is the process of getting a device to tell you where you are. Now, this is one of the places where these devices, these mobile devices, actually have something up on the desktop and the laptop environment, which is that these things actually know where they are. They actually know a fair amount about where they are. They know where they are. They know often what their angle is, how you're holding, lots of information about how you're holding the device. They also can figure out where you've been. So these are some things that you want to have access to, and it's often what drives people towards native applications or hybrid applications, because they want to be able to capture control of that. But both the Android, the latest versions of both Android and iPhone SDKs, the browsers support a HTML5 geolocation. Now, HTML5 geolocation is basically the device tells the browser, this is where I am. The browser doesn't necessarily know anything about where it is. It uses the device to give it some clues as to where it is. And so then the device figures out how to do that. Now, you can send some options to it. You can send, you can send some refinements to that. I'm going to walk you through a few of the things, but I encourage you to check out the spec on it. And also, after this session, up in the Hacker Alcove, we're going to be doing a quick code lab in the Hacker Alcove. So if you want to sit down with some people from Geo, including myself, to help you out with that, to get started using geolocation and working with Street View on the device, follow me after this session. Okay, so as I said, there's HTML5 geolocation, and then for things that can't access that, there's also IP-based geolocation. Now you can see where that might fail. I displayed something earlier, which showed us. Let me see if I can pull that up again. In Rancho Cucamonga. I'm going to admit right now that I'm not actually sure where that is. I think it's in Southern California, based on, sorry? LA, okay, so it's in LA. So you can see the danger. You can also see that different browsers will provide you with different methods of finding your geolocation. And I pull up Firefox because Firefox also provides generally something better, and also because I hadn't gone to this page before here. Now, you'll see here, it gives you an actual option. First time you visit a page, it'll ask you, do you want to share your location with this? All the browsers will do this now. So this is a privacy mechanism, but it's something that you need to anticipate. If somebody doesn't want to share their location with you, then code around that. Right? What is it that you sent? What's your default? And that's really up to you. So here I'm going to click on Share Location. And Firefox also places me in Rancho Cucamonga. Oh, that's interesting. Okay. So earlier it placed me right in San Francisco, but now it's placing me in Rancho Cucamonga, which probably means that they're getting it from the same location, the same way. Now, the different ways they get it are the different browsers will have services that are sort of on the back end. They'll do an IP lookup. That's the sort of the coarsest, worst way to determine your location. They'll look at the IP address of the request and then return something. And then another way is to look at the local Wi-Fi networks and try and make guesses as to where you are. And apparently there are similarly named Wi-Fi networks around here. Okay, I am going a little over time, so I am going to try and power through this. I just want to show you some of the code. This is how simple it is to get HTML5 geolocation. This one line here, navigator.geolocation.getCurrentPosition, and then you pass it a function that it then calls when it has it. And that would be like show map, which would do something. There is, however, a lot more functions in geolocation. So you can do things like watch the position. So just keep coming back and changing the position when it changes. You can look at the age of the position. So if the device provides you with some of the age there, you can get directly the timestamp when somebody was at that location. And finally, the accuracy. Now, you may have seen in this one, it makes a guess as to the accuracy. And then what I did was I took advantage of JavaScript's new circle overlay to just draw a circle around it based on the accuracy in meters. So what it says is somewhere within this radius, this is where you are. Now, of course, this is not accurate. But generally, particularly if you have GPS-based access on the phone, it will be within a fairly, on a mobile device particularly, within a fairly narrow area, within a few blocks usually, and sometimes very tight around that. So I recommend when you're doing this kind of application to take advantage of the accuracy measure in order and actually display that to the developer, because that to the user, because that will give them some indication of how accurate your position is. And then if you're operating on a browser, as you see here, some of the browsers do support HTML5 geolocation, but some of them, like IE, do not. So, and some of the older browsers do not. So you can use, we also have a ClientLocation, which is actually part of the AJAX APIs. And what I recommend doing is see if you have HTML5 geolocation, and if not, fall back to something using ClientLocation. There's a lot more things in HTML5 I don't have time to go over, but basically you look for more HTML5 support in applications, and I don't have time for this last demo, so I'm just going to go ahead and switch over to Chad. So Chad?
Thank you. So I get the joy of showing you an actual use case of what it takes to make a version 3 map actually function on mobile devices in the real world scenario. I work at a university, and we're using it for our campus map. We have, at the university, as far as mapping is concerned, two distinct groups of audiences. Our internal audiences would be faculty, staff, and our enrolled students. And they have strongly told us that they prefer an application to run on the device. They don't want a bookmark, they want an actual application. However, at the same time, I have visitors and guests to campus who may be coming to take a tour, coming to a sporting event, coming to a theatrical performance. They're going to show up at the parking lot and open the map in the browser, and there's nothing I can do to change that behavior. So I have two distinct use cases. This is the scenario where the hybrid application comes in really well, especially considering that I don't have hundreds of developers. I only have the resources to maintain one map application. So the hybrid application lets me kind of do both. The first thing you got to do is I have to migrate my version 2 map to version 3. There's an entire session about this, but some quick high points. All my data sets are identical between I still have a functioning version 2 of the map. If you visit it in your browser, you're going to see the version 2. The same JSON data, the same search index, the same KML layers, all work between both, no modifications needed. Early on, there were some problems with the version 3 in that a lot of the features were write your own. That's not really a problem anymore. In fact, it's really easy if you're using KML layers. Probably the biggest development challenge is the small screen and the user interface and making it touch-based. So with that in mind, let's look at the hybrid application. Now, I had some pretty big concerns about doing this. The first being performance. When it was loaded in a browser, I knew my users would give me some slack with the performance because it's a web browser and you just kind of expect this. But I was really concerned about when it's an application, because then they're going to be directly comparing it to the native Maps application on the phone. So if my hybrid application is slow, there's going to be a pretty low tolerance for that. That one, it turns out, is pretty easy to work around as long as you take some thought and go through all the optimizations. And we'll talk about a few of them here in just a second. The performance within the browser is pretty good, especially for return visitors. When you do some of the HTML5 local storage and caching, it works pretty well. The last one is purely psychological, and that is a developer, this method feels like cheating. I had to get over the idea that my native application is really just a glorified bookmark. However, I put the graph on here to show you. Let me see if I can use.
The bottom button.
OK. The blue line is the segment. That's all the traffic to my mobile map. The green line at the bottom, that's where someone opens it in their web browser. And the orange line is usage from within the application. So you can see that my users don't really care that it's just a bookmark. They much prefer the actual application. And when I'm beginning to see this type of data, that psychological barrier just kind of goes away. If your users like it like this and are using it like this, then that's definitely the way to go. Let me show you now kind of what this looks like on a few different devices. All right. There we get the whole screen. OK, so the icon on the left is the actual application. I'm going to look at it. This is the bookmark saved to the home screen. So in this case, the iPhone shows a splash image and will block showing you the map until the load event in the window occurs. So I'm not going to see as much feedback while it loads, and we'll see how the wireless network does. Oh, and it's going to ask me if I want to use my current location. So here we go. And in this case, you can notice the interface. Now, I can turn on different layers. Let's see if any shuttles are actually running on the campus right now. Oh, yep, I got 2 routes running. I can look at the parking lots. And I can actually search for a building, although I'm going to show you that on the iPad because it's a little easier to type. Let's look at the same thing on an Android device. And in this case, I'm going to actually show you the application. It is identical to the iPhone. Here I had it preloaded because Android remembers, so it's already got my layers up and my buses are running. And also one other thing, I have even more layers. We can turn on the bike routes. Oh, that's the one complaint I have is my controls are too small. There we go. So now I can see not only the bike layers, but I can see the bike racks on campus. And when I get to the edge of my campus bike map, it automatically goes to the Google Maps bikeways layer. And finally on the iPad. And in this case, I want to search for an actual location. And I'm going to use the building code that would show up in our class schedule. I don't know where that building is. And there it is. And last but not least, let's find out where we are. And since I'm nowhere close to my map, it actually puts us in San Francisco. But that gives you some idea of how the geolocation works with this. In order to make this work well for users, though, I have spent a considerable amount of time on optimizations. And in fact, it seems like every other week I'm finding a new thing to do or to try. So here's some of the top ones that I found that make the most impact. The first one was use KML layers for complicated data. Complicated does not take much. Before KML layers, a typical use case would be to open the map. There would be a tile layer, about 6 relatively simple polylines showing the bus routes, and maybe 30 markers on the screen. Even on some of the fastest Android devices with that data, there's a noticeable delay when panning. Loading wasn't great. Drawing, SVG seems particularly slow with the polylines. But with KML layers, just really snappy. I essentially have the overhead of a single tile layer. The second one is to compress your JavaScript. My JavaScript, not the Maps API, but my JavaScript is around 36K. I've cut a lot out of it, uncompressed. But with using Closure Compiler and the advanced optimizations mode of Closure Compiler, I can get it down to about 13K. If you're interested in using Closure Compiler, there's already a extern file available for the version 3 Maps API. It was up to date as of Sunday. Obviously, the announcements this week aren't there yet. Another optimization, which really has nothing to do with speed, more to show users progress, is you can delay loading so you're not blocking. Script tags in mobile browsers still block page rendering. So you can kind of delay that and show some progressive loading. For instance, I'm loading the Maps API bootloader code dynamically adding the script tag at the DOM content loaded event. And then I dynamically add my script tag when the Maps tiles loaded event occurs. So the user just sees more and more features coming into the map. It's not any faster overall time, but they see more progress, and it gives a better user experience. And then kind of the last one is use and love Google page speed. It has a whole lot of optimizations that it'll tell you, and even some of the smallest changes can make a significant difference on your slower devices. One of the slowest and most frustrating is the iPhone 3G, not the 3GS. Just anything you can do to speed that up is well worth the effort. Also, if you're interested in how any of this is working, my JavaScript source code is compressed with Closure Compiler, but there's a comment at the top of the file to a blog post that lists out all the uncompressed source that you can go take a look at and see any of it.
Okay, thank you, Chad. So I want to mention this. We're putting this into pretty much every geo slide. So if you want to, slide deck, if you want to tone this out, that's fine. Basically, we have a developer qualification program. And that program is designed to basically, similar to certification programs, just to identify developers who are accomplished and who contribute a lot to the developer community, and then allow them to have ways to be easily discoverable. So if you want to find out more about it, we're launching at Google I/O, we're launching the developer qualification for V3. So I urge you to take a look at that and get qualified. Okay, so we're now going to switch over to looking at questions that anybody might have. So I'm going to switch this over to, it's number 2, right? No? Number 1? Number 1. Okay. But also, if you have any questions, feel free to come up to one of these microphones here and ask us any problems you've had with developing for multiple devices. Please let us know. I'm going to refresh the browser. So you want to come up and chat, and we'll answer any questions. What's the deal with the sensor flag? Mm-hmm. Okay, so that's a really good question. Basically, the licensing terms that we have with a lot of our data providers requires us to indicate whether or not we're using a sensor or somebody is using a sensor to detect a location when they're displaying something on a map. So in this case, if you're using geolocation, which I probably should have mentioned earlier, you need to set this to true. Otherwise, set it to false if you're not using a sensor to detect location and then display it on the map. A lot of people think that actually provides you with access to the location, but setting that there is just about when you're loading the map. Let's take this question here.
I'm just wondering with hybrid applications,
yes,
if either you could comment, how hard is it to get data into the Android Webview and back out? So you bring up a map.
From your device?
Yeah.
It's very easy. You can expose a JavaScript interface to any of the native services and to your data stores. You just basically write. I'm just thinking in terms of Android. You just write an additional function in and then expose it as a JavaScript interface.
There's actually an article on the version 3 site that talks about developing a hybrid application, and it's not very long, but it shows you the full process to get a working map in an application.
Can maps licensing be simplified so that you can buy a license online? Is Dan Chu in the audience? No. There are enterprise people here who you can talk to about that. We're aware that the process of getting licensing for the Google Maps API Premier is not easy and also presents some unique challenges for mobile developers. So try and see Dan Chu here. He's actually the PM for Google Maps API Premier, or talk to somebody else about that afterwards. But yeah, I would love to see that. In the browser-based API, why does pinch-to-zoom only work on the iPhone browser and not on Android? That's a problem that I believe that we're working on. Mark, do you want to comment on that? Mark, one of the core developers for Maps API. Oh. Oh, yeah.
Yes, so for pinch to zoom, we require special browser JavaScript events, which on the iPhone are the gesture events and the touch events with multiple touch. And those events are not currently exposed by other browsers such as Android or the other mobile platforms. So we limit it for the moment to only support pinch to zoom on the iPhone because it's the only platform where we receive those events. So even on Android devices that have pinch to zoom behavior so that you can scale your browser and see characters bigger, at the JavaScript level, we don't receive those events. So I believe it's coming up. I haven't seen for the moment any other browsers other than the iPhone that expose those events.
There's actually an issue in the issue tracker for the Maps API v3 about that you can follow to keep up to date about where that issue stands.
Obviously, as soon as we can see those events, we just turn on a flag and start processing them. So we're ready for it.
So this is one of the advantages, actually, of using the JavaScript Maps API, which is that we do all that kind of work for you, right? So when there's a change to browsers, or when we can add new features to it, we can add them to them, and it'll just happen without you having to make changes to how you implement the API.
Another real-world example of that type of updates is last week when KML layers became available in version 3, I was able to roll out the update to where my map now uses full KML layers without any change to the hybrid application whatsoever, because it's just using the JavaScript API in a browser.
Can you provide images or video, say via Street View, of the inside of a building once located by GPS? Will the API let me report where I am in the building? So currently, the Street View API does not allow you to move inside panoramas that aren't already in the API, aren't already in Street View. So, sorry, Mark? Oh, you do? We do now. Okay, sorry. We do allow you to do that. I apologize. I missed that part of it. So yes, you can do that.
One note is, though, that when you're in a building, the geolocation from even mobile devices becomes less accurate.
Right. One might even say particularly from mobile devices.
Yes.
becomes far less accurate. And I think... Right. Yes. So Mark is saying, just to clarify the issue, we don't provide, at this point, we don't provide views of the insides of buildings, but if you create your own, you can create those panoramas yourself. And they are in the documentation, and Tom, who wrote the documentation, is actually sitting right here in the audience. Thought I'd call him out, because he's giving a talk later today, right, on Map State API. Right. So the reference went live today, right, for Street View? In about 20 minutes? Okay, so in about 20 minutes, the reference will be live for Street View. Okay, did any additional questions get added in?
I didn't see it.
Any more questions? We got about 5 minutes. So let me, what I actually wanted to do with the demo was to show you a little bit about the code on this one. So let me just do some view code on it, view source rather. Walk you through a little bit. Right. So this is on the geolocation demo that I was using earlier. And let me just get used to a Mac here for a moment. Okay, skip through this. I wanted to just show you here, you'll see the function do geolocation, which basically says if there is navigator.geolocation, then get the current position, and you'll see here it has two callbacks. Position success and position error, and position error returns an error message if it's not able to determine something even though it has the geolocation, otherwise produce a particular error. The more importantly though here is the position success. I should stay on one screen here. So basically here you just do, move the cursor out of the way. It gives you a position object, which gives you access to chords. And then you set a lat long. And then I took the accuracy here, set the center, create at the new lat long object, set the zoom level to 12, created a marker, and then created a circle which had a radius of the accuracy of the measurement. That's really all it took to do that geolocation. And another thing I want to note here is that here's the code for using the default UI. You don't actually have to do this, but I wanted to call it out. I did not disable the default user interface, and I did allow for this Street View control. And what that means then is, on this here, because this is displaying as a slightly smaller map, you'll see it's displaying the smaller controls. If I were at a greater resolution, it would display a larger controls. Let me see if I expand this, if I can get it to. I think it's because I had zoomed out. Okay, so you see here, when I get it at a slightly larger one, the controls over here on the left-hand portion of the screen, they change. And here's the pegman that gets added for the Street View control there. So it's very simple to set up a map that takes account of geolocation and then also automatically changes depending on the screen size and the size of the actual map itself. Yes? The question is, can you programmatically change the direction the Street View is pointing and make it move? And the answer is yes. And in about 19 minutes, check the documentation for how to do that. Yeah, you have quite a bit of control. And as noted in earlier sessions, if you put a marker on a map, it'll show up in the panorama as well. So you have this nice sort of cross experience there. The markers don't just disappear when you move into some other field, which is a nice change there as well. Any other questions? Yes.
Can you have in the browser set up tabs so that when you have it on the mobile, they are as tabs, kind of as an interface, or it's going to be only the map, and you're going to have the same icons fit for the
I'm sorry, I'm not
Okay,
following.
so can we have, when you program and you do it like this, when you look at it on iPhone or Android, it's going to be just the map. There's no tabulation. It doesn't give another user interface.
Yes, you can. So basically, you would do it in JavaScript. You can detect both browser size. You can also look at user agents and get some idea of what the size is that you're looking for, and then dynamically change your style sheets to switch over to, say, a tabbed interface or some other interface that might give you a different experience based on the actual size.
Okay, and that will become active depending on the device you're looking from.
I mean, you would develop that based on your user interface design. Yeah, that's independent of the Maps API. Okay, that's all the time that we have. If you have any questions, feel free to ask Chad or I. I'm also going to be sort of sliding up towards the Hacker Alcove, which is the next session. Thanks a lot.